Welcome to part 3 of calculations and measurements and sig figs. Today I'm going to talk about a little bit more on sig figs, why they're important, and about multiplying and adding them. So last time I told you to take a screenshot of the rules because I feel like I would be wasting time if I wrote them all out again. So let's go ahead and get started. So let's start with adding sig figs. So say you have 6.124 and 3.92. So if you remember, sig figs are taken after how reliable your measurement tool is. So for this 6.124, your tool was reliable up until the 2, and the 4 was something you guessed. After the measurement became too small for you to be sure on your measurement tool. Similarly, same thing on the 3.92. The 9 is where you knew exactly where your measurement stopped, and the 2 is something that you kind of guessed afterwards just by eyeballing it. So when you add sig figs, when you add or subtract sig figs, you can only keep decimals of the smallest of these. You can only keep the smallest amount of decimal places, so only 2. So if you were to add these, you have to add 9 point. This would be 224. That's 10.04. So now the reason we keep only 2 places is because if this measurement was only reliable up to 2 places, if you're adding it to something with 3 places, how can you know for sure that if you actually wrote in this 3rd place, that it would actually be something reliable? If you guessed that if you were to guess that this was 0, then yes, you could add them up, which means the 2 is what's reliable. But it's not. That 2 is a guess, which means that anything that gets smaller than that is not really reliable, so you can't know that this could be a 4 or a 5 or a 6 or a 2 or anything like that. And that's why you can only add to the smallest to the largest amount of specificity, which means the smallest amount of decimals. So now let's go on to multiplying and dividing sig figs. So let's do 5.036 and 4.2 and okay, that's good. So you multiply them. Now, for multiplying stuff, it's a little different. It's not just about only keeping this decimal place. You can only keep as many sig figs as this entire smallest number. Again, it's because of reliability of the tool. You don't know what comes after here, what comes after this 2 for sure, because the numbers just get so small. So multiplying that will affect this entire number, not just the decimal places over here. So that means you have to round up to the same amount of significant figures as this. So you know that none of the stuff over here affects the calculation over here, if that makes sense. So let me multiply this out. Give me 1 second. So that this is the calculator result of this is 21 1.1512. Now, like I said, you can this 1.152. This might all come from stuff that you can't really be sure of, that because you're assuming that the calculator assumes that that's zeros, so all of this stuff is multiplying by these zeros. So it's not, you can't really be sure that that's actually true, and that's why this let me erase that. That's why this has to be rounded only to 21, only to 2 sig figs. So this becomes the answer to this in proper sig fig notation in chemistry would be 21. Now you might be thinking, whoa, that's really crazy, but this is actually the most reliable answer. Even though there are decimals here, like I said, you don't know that these are zeros for sure, which means that this is actually more specific or more a more reliable piece of information than this, because in this one you don't actually know if that's a 1.512 or if it's something else, and that is multiplying and adding of sig figs. So let me just double check my quote-unquote lesson plans. Yeah, so that is everything I wanted to cover. This is kind of a shorter video just because it's a smaller piece of an extension of the last video. But starting next video, we're gonna go and cover the structure of atoms, the evolution of how we think of the atom, and it's gonna be pretty interesting starting now. So I hope you enjoyed this video. If you did, please leave a like, comment, and subscribe, and I'll see you on the next one. Bye.